Good afternoon, this is Dr. Heidelberg, and the presentation today is Conveyor Pick and Place. This is our second lab tutorial of RoboDecay simulation. RoboDecay is a software for simulation and offline programming that we're using in this presentation. The objectives of this lab tutorial is to start with viewing a real robot conveyor interaction process, creating 3D object in a CAD system, configuring the conveyor pick and place processing with the new object that we created, writing the RoboDecay pick and place program, simulating the process, and writing a report. The lab procedure includes the creation of a 3D model, creating the process scene, uploading the objects to the scene, setting up the reference plane, including the tool center points, teaching the robot the position, writing auxiliary subroutines, writing the main program using the auxiliary subroutine, simulating the process, recording the process, and finding its cycle time, and then writing a report. We will start by looking at a real conveyor pick and place process. It was shown in the assembly show this year, 2018, October. And you can see here Universal Robot booth at the center. On the right we see a booth of a manufacturer that deals with robot grippers and tools. We see that there are a lot of conferencing and videotaping. This is one booth that shows a demonstration of the conveyor using Cartesian robot and articulating robot. We'll take a quick look at this demonstration. We see here that the articulator will be picking place from a conveyor, putting in another conveyor, and the articulating is supplying it with the parts. So that's the combination of several robots and in tandem with several conveyors. The first step that we will do here is go to one of our CAD systems and create a desk on top of which we'll place the objects. Once we have the object that we created ready, we can continue with the main work area and download the other objects, the conveyor, the gripper, and the tool. The way we upload is we coming into the globe and the RoboDecay, and the objects are given to us over here in a menu. There are a lot of robot, Cartesian, articulating, grippers, as we see, conveyors and objects. The objects are placed on a scene with reference frames. We could move the reference frames by clicking this icon over here, and we could use these arrows in XYZ coordinate system or the rotational coordinate system as shown here to position the robot and the various other objects at the desired position. To teach the robot its position, again we move the robot either with the joint coordinates. We move the slides that we seen over here, and bring the robot gripper right on top of the object that we like to grip. We can then go to the Cartesian system and move the robot with the arrows which are attached to the tool center point. And that could be done over here linearly, either with the wheel or using the arrows that are attached to the tool. Either way is fine. And the result will be then the positions of the robot shown with the arrows of the coordinate system, including the parts and the tables in the configuration that we like to set up the process. When the process is set up, then it's possible to start writing the programs. And the first step of writing the program is to write the subroutine. The pick, the place, reset, and conveyor move will be the subroutines that we will write for this application. The pick subroutine starts at the home position, and it goes then to the approach position of the table. It comes down to the table pick position, it grips apart and goes back to the approach position. The place position, conveyor place, this is the routine over here with all these commands. We bring in the various commands. The first command is move the robot in joint coordinates to the conveyor approach, which is right in here. Then the second command is to set up the speed to 100 millimeters per second. We like to come nice and slow. The next command is to move the robot to its pick position, which is downstairs. Then the robot is detaching the object right on the conveyor belts with this command, detach. The next phase is a pause of 3 seconds. And the final command is to move the tool center point of the robot back to the approach position. This is the place. The reset is another subroutine that includes 2 commands. One command is replacing the object. Another command, we may show or hide the object as we need to have a continuous flow. So these are the commands of the reset. The final subroutine is the conveyor move. There are 3 commands. Move the conveyor to linearly to the load position, then attach the part to the tool center point of the conveyor. This is the second command. And the third command is to move the conveyor to the unload position. Once we have the subroutine done, the main program is rather simple. We call the table pick, we call the conveyor place, we call the conveyor move, and we call the reset. The next phase is simulating the process by clicking the main program, and the robot will move and trace all the path of motion going from the home position to the approach position, picking up, going back, then coming back to the conveyor approach position, unloading the part, going back, and then the conveyor start moving. When we're done with that, we could generate the HTML presentation to present it to customers or other people that are interested in it. Finally, we'll write the report. We have the lab objective as in page 2. that we would like to clarify that the screenshots and the setup of the target points as shown in page 8. We like to see the software of the subroutines and the main program, and then finally the HTML simulation. We'll take a look here at the presentation. We download the main, and this is the simulation. The parts comes, and this is it. To show the final product, we could start the HTML, and we see that again we could stop the machine and go slowly to the final point, and we read here the time 47 seconds to go through that process. This completes our presentation, and we hope that you will find it useful in experiencing the RoboDK conveyor and robot process. Thank you.